Okay, so last thing we just a moment, where we are here. Yes. Okay, over here. So we said we used Minsky equation to determine the minimum number of stages, and this is Minsky equation to determine minimum number of stages, and then this is step 1. Step 2, we used Underwood correlation to determine the R minimum, and that was the only complications we had. Today we will see if we have now the minimum number of stages and we have the minimum number of reflux ratio. What would be the reflux ratio, or sorry, what would be the number of stages at given reflux ratio based on these minimum values? So it's basically what we're trying to do right now is to determine the reflux ratio, sorry, to determine the number of stages based on this reflux ratio. Now, what you see here is a figure that is being generated by, as you see here, approximated by several, as you see here, 61 data points taken over the following days. So they went and did some experimental work, and they tried to come up with this general figure. But here is the conditions at which this figure is generated. And as you see, the number of components, there were between 2 to 11. Relative volatility used in the experiment was between 1.11 to around 4. Q, which is the condition of the feed, between 0.28 and 1.42. Pressure from vacuum to up to 600 psi gauge, and the minimum reflux ratio between 0.53 and 9. Minimum number of stages between 3.4 and 60. So you have these conditions, or you have these limitations of your approach. So if you're going to determine the number of stages, you'll have to give me your reflux ratio, minimum reflux ratio, and minimum number of stages should be within these two ranges here. Why? Because it is like any other correlation you seen before, whether it is related to, for example, heat transfer, where you use some correlation to determine, let's say, for example, heat transfer coefficient, or any other parameters. Always you're going to see some limitations of that correlation, and these limitations sometimes related to the range of the temperature, or related to the configuration, whether that correlation is valid for spherical or flat plate, for example, or cylindrical shapes. So it's very common whenever you see any correlation that is being produced or developed based on some experimental data, you usually have some sort of limitation, because it's not, it's based on theory, by the way, but it is not pure theory. It is not developed from scratch based on theory only. And because it is not sometimes easy to do such thing, and so therefore you usually have several correlations or several equations that can be used to determine some parameters. Maybe it's a mass transfer coefficient, for example, heat transfer coefficient, friction factor, anything seen before. So because of the complications associated with this parameter, usually we have equations that can be used within certain range of temperature, pressure, or velocity, sometimes pressure drop, to determine this parameter. And these are called correlations. And this is another correlation that is used to determine the number of stages if you have the reflux ratio. Clear? So as we can see, we have several trials here. We have Van Winkle, we have Gilland, the same guy, data points here. We have Brown here, Martin, and we have Molokanov, seems like a Russian guy. Molokanov is that solid line here. And this is the relationship between this one and this one. Okay. So now this is the equation that was written here. So in order to use it in Excel sheet, for example, or instead of going to the graph and determine these y and x's here, you can use the equation immediately here. If you want to draw it in a log scale, you will see that graph here, as you see. If you want to draw it the same in rectangle coordinate, as you see here, you will see another figure, but the value is the same here. The only difference is the scale that you want to use, whether it's log scale or rectangular. So this is one, we call it rectangular scale, and this one is log scale. Rectangle means normal scale, so just okay. And this is the equation. So you can use the graph to, for example, at certain x, you go up here, you can get your y, and from y you determine number of theoretical stages, or from x you can put it here, and you take the exponent of these parameters, you can get y. So it's up to you. So usually whenever you have something, if you are in the exam, it's good to use the graph immediately because it's going to be very quickly. If you're trying to do something at home, like for an assignment, or want to look for some accurate value of y at certain values of x, it's good that you use the equation which is here. Okay. So any questions so far?
دكتور الافضل نستعمل اللوج سكيل ولا الريكتانجلر سكيل؟
لا هو انت you're not going to generate the graph anyway. You will not be required to generate the graph. You will be required to use the graph. So if you're going to use this graph here, you take the x's now, of course, at certain reflux ratio. Okay, you come to get x, and from x, so you're supposed to have r minimum, as we said, because we know r minimum, given information in minimum, and I have what is the value of n at r. So you know r minimum and minimum r. You come to this one, you get x, let's say it was 0.1 or whatever, you go up here, and you get your y immediately. You can use this graph, or you can, again, for the same thing, you can come at 0.1 here. If it was 0.1, you go this one here, you get your y. So it's the same thing, it's up to you. Or more accurately, you can get that this x, you can use this equation immediately. So I would prefer to use this equation. Forget about the graphs. But the graph is good when you are doing exams. It's a little bit faster. Okay, any other questions? Now we know the number of stages. We determine the number of stages based on R minimum and N minimum, and that R I get N. But I want to know how many stages above the feed stage and how many stages below the feed stage, and that will give me the optimum feed stage. So now we have a certain number of stages, and that number is N. And we would like to know how many stages in the rectifying section and how many stages in the stripping section. So I have another correlation, Kirkbride here. It's a long time correlation, 1944. And as you see here, it's based on the flow rate of WD and the composition of the feed of the heavy component and the light component, and also the composition of the light component in the bottom product, the composition of the heavy component in the distillate product, and then you can have this ratio between the number of stages in the rectifying section and the number of stages in the stripping section, and this is equation 1. The other equation that you have is the number of stages is going to be equal to the number of rectifying section stages and number of the stages in the stripping section. This one is already determined, so you have two unknowns, this one and this one. Now you have two equations and two unknowns, you can solve them simultaneously easily, they are not nonlinear. Then you can get the number of stages in the rectifying section and number of stages in the stripping section. Okay? So, for example, if that number of stages in, let's say you found it from the previous correlation, it was, let's say, 20. And then you calculated NR to be 8. So that means you're going to have 8 here. So your feed stage is going to be 8 or 9, let's say 9. And the rest is going to be 20 minus 9, which is going to be 11. So you're going to have, 12 stages in the stripping section and 8 stages in the rectifying section. And your feed stage is going to be number 9. Okay. طيب, let's go with this very conclusive example. Here you have separation by distillation of chlorination effluent to recover C2H5Cl. So you want to recover C2H5Cl. The feed is a bubble point liquid, so you have to be careful. Now, what is the meaning of bubble point liquid? What we mean by this one? What we're gonna use this information in?
Q equal 1.
Yeah, so you gotta be able to quickly set this one. So you're gonna say now I know Q is equal 1. At the column pressure of 240 psi with the following composition and key values. So you have the composition of your feed plus their key value. So he is trying to simplify this situation for you, and it means you don't have to go and find out the average K values. You have the K values. Now he is also giving you the specification or design specification related to two components, C2H5Cl and C2H6. Now from these two, we have to be able to determine the light key and the heavy key, or at least the key component. So this is the key component, and also this is a key component. Okay, so now I have key component here and a key component here. So these are non-key component and non-key component. Tamam? Now we have to determine which one is going to be the light and the heavy key. Which one is going to be the light and which one is going to be the heavy components? Which one?
First three are light.
Sorry?
The first three are light. Light non-key, light non-key, light key, then heavy key.
Good. So based on this one, based on the volatility. So here, when you compare two components, you compare them with respect to this K values. Now you can see here 3.4 is higher than 0.15. So it means this one is light key and this is going to be heavy key. So this is the first thing in any multi-component calculations. Now before that, if you cannot decide which one is going to be your heavy key and which one is light key, then you cannot proceed in the solution. You have to be careful. You have to know what's exactly the information that you need. And it's a very important issue here, and the problem is related to the multi-component distillation. Now, once we have this one, all what we have to do now is to construct the table. Now, I'm given this value, 0.01 and 75. Okay, keep it here in mind. Now, this is xd over xb, and this xd over xb, of course, this is the ratio of the composition between in the distillate and the bottom. So, D means distillate, B means bottom, or W here. And he wants you to calculate, first of all, the minimum number of stages, and he wants to calculate the minimum flux ratio, and calculate the number of stages at R equal 1.5 R minimum, and locate the feed stage. And he is telling you the column is to have partial condenser and partial reporter. Now, partial reporter is something you should keep in mind. It's most of the time, not most of the time, always partial reporter. We don't have a total reporter. But partial condenser is something that you have to be careful. Sometimes partial condenser, sometimes total condenser. But usually, since we have this C2 components, it's considered to be a light component. Not just light, but it's very hard to condense all of these C2H4. Okay, now, first of all, N minimum. What is N minimum, guys?
Minimum number of
How we
stages.
determine N minimum? Using what?
Fensky.
Fensky equation. So basically, very straightforward, I guess. The first requirement is very straightforward. Let me do it with you one by one using the Excel. So I want you to know how to do that. So what I will do, let me just go back to this one. Yes, let me just discard here. This is the example here. So now what I will do, I will switch to, I think you see here, what I will do, I will stop here and I will start to share the screen. So you probably will be more, let me, yes, here, I guess it's gonna be okay. Good. Now what I see here, do you see the slides again, guys? Can you see the PowerPoint slides here?
لا دكتور مو قاعد تظهر.
Now, do you see it?
No.
Really? Maybe I have to do this one. What about now?
وايت بورد خلينا نشوفه دكتور.
Whiteboard, that means, do you see the Excel sheet? Do you see this one highlighted?
لا عندي أنا لا دكتور.
طيب خلي أغير الطريقة. Maybe what I can do. Sorry. No, not the camera. Share application, I guess. Now I think you should be able to see it. Can you see the slides now?
Yes, الحين إيه.
Yeah, good. That was my mistake. So now what we'll do, I'll try to switch between this one and the Excel sheet. Now you can see the Excel sheet, huh?
Yes, Doctor.
Okay, now what I will do, I will try to go to this one and try to copy this component. Sorry, I have to. So what I'll do, go calls. So I come here and just, sorry. Okay, so paste here. So now I have my components here. All what I have just to organize it a little bit so I can. So I want to go with this with you one by one, so at least you know what is going on here. I wanted to just ensure I have everything online, no fill here, and the K automatic here. So yeah, so now these are my components, and I will go through one by one. So first of all, I have to calculate what now? Let's assume we have feed is equal to, sorry, I have to feed, let's say mole. So I'll assume it's going to be 100 here. So now what I need to calculate here first, guys, I need to calculate, let me just reduce this. First thing I wanted to know is the relative volatility, صح? Is that right? So I have to get the relative volatility. Now, first of all, I have to say this is my light key, of course, and this is my heavy key. These are light non-key, and this is light non-key. تمام? Okay, so this is going to be just very straightforward. Now, I have to get the this information here with me, so I need it a little bit later on. Control C here. I can get it here. Just put it here. So this is important information that I should keep in mind because I'm going to use it here. Okay, guys, you following me? تمام.
وياك دكتور وياك.
طيب خلينا إذا أول شيء we have to go back and try to find out what is the equation for this Vinsky equation. Go back to Vinsky equation. If we go back to Vinsky equation, we'll see this one. So let me just copy this one. Control C. So I then go back to this one, and just to keep it in mind here. So this is my equation here that I'm supposed to be using. Let's make it a little bit. I don't know why it's not working anyway. طيب إذا احنا الآن ال n minimum هذه, as you can see here, requires this one, xd over xb over xd over xb. So let me just tell you one little thing here. So now I have, if you wanted to look at this one, I have xd over xb, and here I have xd over xb of the heavy component, of the light component. So this is the specification for the light component, and this is the specification for the heavy component. Tamam. Now if I look at this one, it's xd xp. So now I can write the same equation in this formula, and you tell me whether it is okay or not. Can I write this one like this one? Can I say xd d over xb w over xd? Of course, this is for the light key, and this is light key, of course, and this is heavy key. D divided by xb of the heavy key double. Can I write this equation in this way? Ln light key over heavy key. Can I write this equation in this way? Is this okay? Is this okay? Reasonable? Acceptable? Can I do that, guys?
Makes sense, doctor.
Okay, so because D would cancel with D, because D is for all components, so D is the total amount of the D. So keep this in mind because we need this one. So now what I will do, I will just say alpha I for each component. That means, let me write it this way. Alpha I. And alpha is basically the key of the component divided by the key of the heavy component. So I will say, I will write the equation. I will say this is going to be this key divided by the key of the heavy component, and I'll have to write constantly. Sorry. Okay, so this is going to be. I have to make it. I fix it this one. I don't know why it's not working. Maybe I will write it now. It should be okay. Yeah. So as you see here, I do it, fix it, because it's going to be fixed for all components. And I just press enter here. So now I get 34. I will do the same thing without writing it everything manually. I just make it centralized. And then I come here and I just pick this one and I copy it here. So you see here, these are the alpha for each component because we need alpha. The one that I'm going to use in this equation, the alpha here is going to be which alpha? Can you tell me which number I'm going to use? Could you tell me which alpha I'm going to use?
For the light key.
Any idea? Okay, so 22.6, exactly right. So what I'll do, I will say my N minimum will be, and I write the equation. The equation says ln, so I have to take the ln of the fractional, which is 75, as you see here, divided by 0.01, because xd over d of the light component. So it's going to be 75 divided by 0.01, and is divided by ln of which alpha, this one, I just click this one here, D8, and then and that should give me the number of stages, so minimum number of stages, which is 2.8. Of course, you can reduce the significant figure. So this is the first thing you do. Is this clear? Any questions regarding the first one?
Clear, doctor.
Any questions? Clear? Clear, good. So now I would like to get the distribution. The distribution, that means I would like to calculate these values for the other components. Now I know the fraction xd for these components here. But what about the other components? I will use this equation now. Now, if I want to use the same equation, so I know that now in minimum here. Okay, I know in minimum. So what I will do, I will say, okay, for each component, I will be able to write this equation. So I say, if I rearrange this equation, I will have ln alpha of each component with respect to the heavy key. Okay, and ln is going to be going here, so it's going to be to the power n minimum is equal to ln, as you see here, xd of the I component over xb of I component divided by xd of heavy component divided by xb of heavy component. So now all what I have to determine now is just this ratio here, because I know this one is given here, and n minimum is determined already, and alpha ik is given here for each component, as you can see. So all what I have to do is just to write down here. I would like to calculate xd I repeat the equation for each component. So I'll say xd, let's call xd, here say xd over xb for each component. And that will be just basically, as you can see here. Now from this one, by the way, from this one, you can see here, I can say now alpha. So ln will cancel with ln, so it means this one, xd over xb of that component I will be the xd over xb, the heavy component, multiplied by alpha of that component or relative to the heavy key to the power n minimum. Okay, so this is what I will write for each component here. You see here what I'll do. Okay, so let's start writing the first one for the first equation. So I will do this one. So I got equals. Now this value here, xd over xb of the heavy component is given as 0.01. So it's going to be 0.01 fixed multiplied by alpha of that component. So this is alpha of that component with respect to heavy component is equal to 34. So I would go to this one, select G6 because I wanted to repeat it for each one. I don't want to enter 34. I can do that, but it's going to, you will have to repeat for each cell. Now this is going to be to the power. So to the power what? This value here. Now this value I wanted to be fixed. I don't want to change. So that will be my distribution for the first component. Now I don't have to do it manually again. All what I have to do, just go and pick this one here. And as you can see here, the value here is the same as the one given here because you use these two values to determine the minimum number of critical states. But these are the new ones here, this one and this one. So now you know the distribution or the ratio at least between the xd and xb for each component. And you got these based on the specification given in the problem itself. Tamam? So now what I will do now, I would like to calculate d and w. So if d and w, I need to calculate what? I need to calculate the now as we mentioned here, xd over xb is the same as xdd over xbw. So here you can say for each component xd multiplied by d divided by xw multiplied by w is going to be the same because we know already from the equation. So this means you're going to say this is going to be equal to this one. And you just write here, just centralize this one. And then you can come and just get this one. Now I have xdd, the ratio. So how can I calculate dxd and dxw? Can I write these ones here? Can I say, I can write xd multiplied by d and xw multiplied by w. Can I do that? First of all, what are these values? These are the components, fluoridative components in the distillate and fluoridative components of the in the bottom product. So it's basically trying to find out this one because that will help you to get D and W. Okay, so let's see from the material balance point of view. So if you go back to your column here, if you go back to this column here, and hopefully you follow me, guys. Okay, you have three components or any component. Let's call that component is I. And this I is basically, let's call it Fi. So the fluoridative component I in the feed, and you have the fluoridative component I in D and the fluoridative component I in W. So first of all, you have Fi is basically Di plus Wi. Okay. What else you have? You have the ratio here. What is this ratio? You have you see here xt over xw, so you know di over x, sorry, not x, over wi, let's call it ratio. Now if I combine these two equations, I can come up with another equation says if I is equal to multiply yi with the ratio plus wi, from which I can get wi now is equal to what? If I divided by ratio plus 1. So now di is equal to what? If I, whatever goes in, minus wi, which is if I over ratio plus 1. Or I can write here di is basically if I multiplied by 1 minus 1 over the ratio plus 1. Now the ratio is given or already determined, and this one is basically x d, and this is of component I, of course, and this is x d di, and this one is basically x w wi. So now I know the ratio and I know the flow rate based on the total flow rate assumption. I can write the equation to get, so this one is basically the ratio here. Okay, and this one is di, and this one is wi, and this one we can say fi. Just x feed multiplied by the feed, total feed. Okay, so if we do that, what I can get here, I can say, is this okay, guys? Clear so far? Are you okay with the equation that I just wrote? Okay, hopefully. So now I will go to this equation and I say this is the equation xd. Basically, if I multiply the 1 minus, so I can take this one here. Sorry, I can't do it. So basically, I'll have to zoom it a little bit so I can come to this one, and I say now I have this equation I would like to write it. So it's if I, that means it is going to be the immediately the percentage here, which is if I multiplied by, as you see here, follow this one here, multiplied by 1 minus 1 over the ratio. We have to put the ratio here. The ratio is this one here, which is the one on the left here. Okay, plus 1. In a bracket here, so this is your value, 4.9. So now this is your flow rate of component C2H4 in the distillate. So that means this one is basically going to be the feed, whatever goes to the feed, minus whatever goes to the distillate. So that means this is what is going to be in the bottom product. So now you got to be careful when you look at these numbers. These numbers should be between, it doesn't have, and it cannot go beyond 5, beyond the feed composition. And then all what you have to do, just repeat it for the other components, and that's it. Now you know the flow rate, moles now, is not just the ratio, the moles of each component in the distillate and in the bottom product. And if you combine them, you will find that it is the same as in the feed here. And now you want to calculate the total D, so this is going to be your D, All what you have to do is just go to home. You go to auto sum, so that will sum all this, and you can repeat this one, and you can find out. So this is going to be your W. Maybe we can write this one is your D, and this is your W. So these are one of the results. Let me just type here the results that you're going to be able to get. I usually do that. Okay, so now I have the minimum, the distillate total flow rate, and the composition as well. Any questions here so far? Everything is clear. Right. Now what we wanted to determine, if we go back to my problem here, I want here. Now I got N minimum, and now I need R minimum. Now in order to get R minimum, I have to use the first Underwood equation and second Underwood equation. Now I have to determine phi or psi. So I have to go back and just go on to this one and just, yes, so I need to get this equation here. So Control C, and just type it here. Just to remind you, this is your equation. And also we need this second here one. So you need these two equations to get the minimum. But the minimum requires phi or psi. And psi has to be done or has to be obtained by solving this equation. So now what are you going to do? We'll just write, you have here, let's say psi here, F here. And this is your Q, because you know Q is equal to what, guys? 1, because saturated liquid. Bubble feed. Now this one is going to be here. Let me just adjust it so you'll be able to assemble here. Okay, so now this is what you're going to do. You try this value, try to find this value. And usually whenever I do iteration with any number, the cell that I do the iteration on, I just highlighted that as, let's say, here. Now, can you tell me why I choose 10? Let me just finish this equation. Now I would like to get this one, summation of what? Alpha Z over alpha minus psi. So this is what I'll do. I say alpha, maybe alpha I multiplied by Z I divided by alpha I minus F here. And then this is it. Let me just write it in the symbol so you understand what I'm trying to say here. If I go to this one, I will choose this one to be symbol here. Also here, I will go to this. I'll choose symbol as well. And this one is gonna be here, symbol as well. So you know what I'm trying to do. So now, this is what we will write. I know Z, and I know phi for each component. The only parameter that I want to determine is going to be psi. Good. So now what I'll write this one, alpha, this is my alpha, multiplied by Z. So the composition is going to be this one divided by 100. Okay. And then this is going to be divided by alpha, which is this one, minus psi here. This is my psi here. And I write F4 just to make it constant for all other cells here. And that's it. Now I will just have to write it for the other components. And that can be done in Excel sheet just by doing this way. Now you want to adjust this 10 here. It's not 10. Now we will see why it's not 10. When you do the summation here, auto sum here. So it is 0.24. Now, according to the condition of the feed 1, now this summation should be what? Should be 1 minus 1, 0. So this one should be 0. Should be 0. How we do that? We can do that by adjusting this number. You know, every time you adjust, let's see if you want to do it manually. If you do it 11, the number is changing, but you want something more robust by iteration. What we do, we can go the data here, and I go to the solver, and hopefully the solver is there. Yes, the solver is here. So I will try to minimize this value. So I choose this value, this cell, and this cell to be equal 0, but I want to this cell to be 0 by adjusting, so changing variable cell by adjusting this phi here. Okay, now once I know what I want and what is going to be changing, I can just start the solver, and as you can see, the solver find the solution, so you just press OK. So you see here, this phi that will give you a 0, because this is 5.6 minus 8, considered to be 0. So now you are satisfied. Now you know this value, phi, okay, by solver. You can do that by any other programming again. I don't mind. But at least now you know phi. Phi is given, sorry, phi is calculated now. Okay. Is this clear, guys? Any question? Type. Now, the last thing is going to be determining V minimum, because all what we're trying to do is to get V minimum here. Now, I know psi determined already, and I know dxd is already here. So all what I do, I just write V minimum here. Can go there and I write this column here, which is going to be alpha, or let's say AI multiplied by dxd divided by alpha I minus f here. And if we do that, just to keep in mind, this is going to be, for example, simple here. Sorry. So what I will do, just let me do it in this way. Sample here. And this one is also going to be symbol here. We want to do it for this one as well. Okay, so we wanted this one xd here is sub. So you want to just make it a little bit easy to understand. So you wanted to subscript here. At least look a little bit more reasonable. That's it. So now what are you going to do? You just write the equation. Alpha I, this is your alpha here, multiplied by dxd, this is your dxd, divided by alpha I, this is your alpha I again, minus phi, here is your phi, and you wanted to write it for all components, so you press F4 to fix it when you do the copy paste here. So this is your phi, the first phi here, the first term, and you wanted to do it for the other components. You want to do it for all components, by the way. Okay, so you just click here. Now you're going to do a summation. You can do auto sum here. If you don't know how to do auto sum, you can write sum all the areas. So this is 23.6. What is this? This is the summation. So this is your V minimum here. And how we get the R minimum? If this is a V minimum, how we get R minimum? We know this is your D, and this is L, and this is V, and their flux ratio is basically L over D, external flux ratio, and you know V is basically L plus D. Now if you divide it by D, you get V over D is equal to L over D plus 1. So that means this one is their flux ratio that you are looking for, will be V over D minus 1. So all what you have to do is just go, you know V now. Since you are using minimum V, that will be minimum as well. So that means R minimum, I can go and I say R minimum is basically V over D. So R minimum here, I can say R minimum is going to be V over D. Where's V? This is my V. Okay. Over D divided by D. This is my D here. So I write it here. Minus 1. Why I'm saying minus 1? Because that's what it says the equation here. So the final value is 0.147. So I know R minimum now, and I got V minimum, all what I wanted. I can highlight them here as the output here, just to ensure this is the result of my calculation. So here is the, okay. So now I got R minimum and N minimum, and now I want to calculate N at R is equal to 1.5 R minimum. So all what you have to do now is to use this correlation here. So now you have R minimum, you get X. From X you can get Y. Now Y, there's only one unknown in this, is going to be N, you can get N. Is this clear, guys?
دكتور الار بطلعها من الجيفن ريشيو صح بين الار مينيمم والار.
Are you okay? Any questions so far? Okay, so now I've determined all these. I went through all these together, guys. We determined all these Excel sheet, and we got all the values. Now, there's only one note that you wanted to understand is the initial guess of this. When you do the iteration, as we showed you using solver, you need to know which the initial value that you must use. You have to be careful. It's supposed to be between this value and this value. So it must be this number here. This is the initial guess. Must be between the light key alpha and the heavy key. So it's between 1 and the heavy light key alpha. Okay. Now that's it. And the summation that will lead to 0. Why it should lead to 0? Because Q is equal 1, and the equation say 1 minus Q, and then this one must be 0 here. So now I have all the other calculations. You'll see it here, and we did that, and we were able to find that R minimum was 0.147. Now I have the I want to determine the number of theoretical stages based on the flux ratio that is 1.5 times R minimum. Now I have R is equal to 1.5 times minimum. So all what I have to do, just multiply it, it's going to be this value. I go and get X value based on this R. So X is going to be 0.0603. I use the equation instead of the graph. You can use the graph if you want, but usually whenever there's equation, it's good, more accurate, more easy, and fast. So from this, when you substitute this value here, this is the y value. Now, y value, we know it is n minus n minimum over n plus 1. You solve for the unknown value, and the number of theoretical stages will be 8, as you see here. Now I want to get the optimum feed stage, so I have to know how many stages in the rectifying section and how many stages in the other section. I use this ratio. So I know this ratio from this equation. I know D and W already determined the composition of the heavy key and light key in the feed. And the composition of the light key in W and composition of the heavy key in D, and I know everything here. So I can get this ratio. So now I have N over NS is equal to 0.5, and I know NS here plus NR is equal to 8.5, and I know NR over NS. So I have equation 1 and equation 2. You can solve them simultaneously. You'll be able to find out the number of stages in the top and the number of stages in the bottom section. Okay. And of course, the summation should be 8. Of course, if you add these together, you will find it's going to be 8. And 5 plus the 8, and this is going to be 7.0, and so this is 8.5. I think I'm done. So if there's no more questions, you're free to go. If you probably, I think you have some exams. So. But this is it for me. Any questions so far? I intentionally tried to go through the calculations using Excel sheet because it's something you will benefit from if you learn how to do it. It's not big deal, straightforward, and it's available for free. I mean, Excel sheet, and it's good. It's going to help you in other courses as well. It's not only in this course. Okay, any questions so far? Then thank you very much. Have a good break. Hopefully you will be able to recover during the mid-break session. I know it is in the peak time now. You have exams and quizzes and everything now, but this is it. This is student life. You have to cope with this, and you have to learn how to live with this stress and the challenges you face in your study, inshallah. And you will be okay, inshallah. As long as you work hard, everything is going to be fine. So thank you very much, and see you after the mid-break session, inshallah. If there's any questions you have in mind or you want to ask, I'm still available even during the mid-break session, inshallah. Okay, guys? Thank you very much.